In this video, we're going to look at some additional trigonometric identities, specifically the opposite identity, supplement identity, and complement identity. So we're going to start with the opposites identity. So we're just talking about angles that are opposites. We're just talking about angles that have the same magnitude but different signs. So in this particular case here with this diagram, here we have an angle that's 37 degrees in general. We'll just call that theta. And then this angle here going in the opposite direction would be negative theta. In our specific example, 37 degrees and negative 37 degrees. What we'll notice is that the x coordinates here are exactly the same, while the y coordinates here are exact opposites. So if we remember that the x-coordinate corresponds to the cosine value of the angle and the y-coordinate corresponds to the sine value of the angle, then we can come up with some more properties here. So the x-coordinates are the same, so remember those are the cosine values. So that tells us that the cosine of negative theta, so the cosine of this angle at the bottom, is exactly the same as the cosine of the angle at the top because the x-coordinates are the same. So cosine of negative theta is the same as the cosine of theta. The y-coordinates, which are the sine values, remember, are opposite values. So here we're going to say the sine of negative theta is the opposite of the sine of theta. So here we change the sign. So then remember my tangent value is y divided by x. So up here that's going to be 0.6 over 0.8, and down here it's going to be negative 0.6 over 0.8. So again, they're opposite values. They have different signs. So the tangent of negative theta is also equal to the opposite of the tangent of theta. So these three statements are your opposite identities, and they would be on the formula sheet. All right, so the next thing we're going to look at here is the supplement identities. So remember from geometry, supplementary angles are angles that add up to 180 degrees or pi radians. Supplementary angles are reflections over the y-axis, and when we talk about a supplement angle, we're going to refer to it as 180 minus theta, or more often you're going to be working in radians, so you'll see the pi minus theta. So again, we have a specific example here. So the angle theta in this specific case is 40 degrees, and then the supplementary angle is going to be pi minus theta. So here what we'll notice is that the x-coordinates are opposite values, while the y-coordinates in this case are the same. So remember, the x-coordinates correspond to my cosine value of the angles, and my y-coordinates correspond to the sine value of the angles. So in this case, we'll say the cosine of the supplement, which is pi minus theta. So this value here is, remember, the opposite of this value here, so equals the opposite of cosine of theta. The y-coordinates are exactly the same, so that's going to be the sine of pi minus theta is equal to just the same thing as the sine of theta. And then again, my tangent values are going to be 0.65 over 0.76 here, and negative 0.65 over 0.76 here. So again, they're opposites. So the tangent of pi minus theta is the opposite of the tangent of theta. So these are my supplement identities, and again, they would be on the formula sheet. All right, so the last one are my complementary identities, or sometimes you'll hear them referred to as cofunction identities. So remember, again, from geometry, complementary angles are angles that add up to 90 degrees or pi over 2 radians. Complementary angles are reflections over the line y equals x. So remember, the line y equals x would be here. So we're reflecting over this line, which, remember, is the inverse. So the x and y coordinates will switch. So again, when we talk about complementary angles, 90 minus theta, or more likely in radians, pi over 2 minus theta. So here my example angle is 20 degrees, so in general refer to that as theta. And then the complement angle here would be pi over 2 minus theta. So these are a little bit different because remember the x and y coordinates are switching. So this x coordinate 0.34 here is the same as this y coordinate 0.34 down here. So this x-coordinate would be the cosine of the complement, so pi over 2 minus theta. And that's exactly the same as the y-coordinate of this point, which would be the sine of theta. And then we can do, similarly, the sine of pi over 2 minus theta is equal to the cosine of theta. And then finally up here, my tangent's going to be 0.94 over 0.34. And here it's going to be 0.34 over 0.94. So these are reciprocals of each other. So the tangent of pi over 2 minus theta, so the tangent of this value up here at the top is the reciprocal of this tangent from the bottom. Remember, the reciprocal of tangent is cotangent. So this is equal to the cotangent of theta. So then these are my complement identities, and they will again be on the formula sheet. So we're going to look at using these three identity statements to do some evaluating of specific trig functions. So in this example, we are starting with the sine of theta as 0.45, and we're looking to evaluate the cosine of pi over 2 minus theta. I like to always start with whichever expression looks more complicated and that I can match up with on the formula sheet. So in this case, I'm going to start with the expression they asked us to find. So cosine pi over 2 minus theta. If you look at your formula sheet under the complement identities, the cosine of pi over 2 minus theta is equal to the sine of theta. So that's just from your formula sheet, and now we know the sine of theta value, so I can just substitute that in. So I get cosine pi over 2 minus theta is equal to 0.45, which is what I was trying to find. So just with identifying the one trig identity and then doing a substitution, we've got our answer. All right, so here's another example. We're starting with cosine theta minus pi, and we need to find the cosine of negative theta. So again, looking at these, theta minus pi looks somewhat similar to some things from my formula sheet. So my supplement identities are pi minus theta, so this looks something like that because it has the pi in it, but it's not exactly identical. So we need to do a little bit of work to make it match up exactly with what we have on the formula sheet. So we're going to start with cosine of theta minus pi. So anytime you have a subtraction that's in the opposite order from what you have to reverse that and factor out a negative. So here's how we'll do that. So I'm just going to switch the order around here. So this is going to be cosine of negative pi plus theta. So all we did here was switch the order. Next, I'm going to factor out the negative in the parenthesis here. So this is cosine negative, and then if we take a negative out of this, we'll get pi minus theta. So now this is looking closer to what we have on our formula sheet except for this negative sign. So then we're going to use our opposites property, which says the cosine of negative theta is equal to the same thing as the cosine of theta. So this cosine of theta minus pi. So the opposite property says I can just get rid of this negative here for cosine, so I can just write this as cosine of pi minus theta. Then using my supplement properties, I know the cosine of theta minus pi is going to be equal to negative cosine of theta. Now I'm going to move this negative over to the other side, so I'm going to multiply both sides by -1 here. So I got negative cosine of theta minus pi equals cosine of theta. Again, using my opposites property, cosine of theta is the same thing as cosine of negative theta, which is what I was looking for, remember? And now I can substitute in because I know this value right here. So now I just get negative. Then I can substitute this in, 0.73 equals the cosine of negative theta. So cosine negative theta is equal to negative 0.73. So this process here of reversing the order of the terms in there and then factoring out the negative and then using your opposites property is going to come into play a couple of times. So it's something that you're going to want to practice. All right, so here's another example. So we're starting with cotangent of theta is about 7.89, and we want to find the tangent of theta minus pi over 2. So again, this is a situation where we have something similar to this on our formula sheet, except on the formula sheet, the pi over 2 is first and the theta is second, and so then the signs are opposite. So again, we're going to kind of do what we did on the previous example. So tangent of theta minus pi over 2. So this was going to be tangent pi over 2 plus theta. Then I'm going to factor out the negative. So we end up with tangent negative pi over 2 minus theta. Then I can use the opposites property. So negative tangent of pi over 2 minus theta. And then I can use my complements property here, which says the tangent of pi over 2 minus theta is the same as cotangent. So this is negative cotangent of theta. So I'm just going to bring this down, tangent of theta minus pi over 2, which remember is what we're trying to find. And now remember, I also know the cotangent value, so I can substitute that in now at this point. So I'm going to go tangent of theta minus pi over 2 equals negative, and then the cotangent value is 7.89. So then I have my answer, tangent of theta minus pi over 2 is equal to negative 7.89.